Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can add and subtract polynomials. Now, there are lots of different ways that we can do this, and you can see that we're going to learn one way that involves treating these like we're doing the distributive property. If you know another way to do this, you are welcome to do it another way, as long as you're still coming to the same conclusion. However, make sure that you are getting those right. So what I find is one of the easiest ways to do adding and subtracting is to think back to our distributive property, which we just learned about. So when it comes to the distributive property, what you end up doing anytime you have an example with the distributive property is you have a number on the outside and something else on the inside. And you take what's on the outside and you multiply it in. So 2 times x is 2x. 2 times 2 is 4. Then you combine any pieces that look like. When it comes to adding and subtracting, this actually ends up being exactly the same way. But what we end up seeing is we have two sets of the distributive property. So in front of anything in math, if there's no number there, so in front of this parenthesis here is actually just a 1. Same thing happens between the subtraction sign and this parenthesis, is we have a 1. So what we've got here is we can actually use our distributive property to get rid of our parentheses, which will make this problem seem simpler. So I've got 1 times 5b squared, which is 5b squared. I've got 1 times negative 2, which is negative 2. We're going to distribute this together. So negative 1 times 2b is negative 2b. Negative 1 times negative 2b squared is a positive 2b squared. Then what we get to do is we have the chance to combine like terms together. So what we're going to do is look for the ones that look the same. So we've got this 5b squared and we've got another 2b squared. Now we want to make sure we're writing these in standard form, which means you want to write them from highest exponent to lowest exponent, which is why I was looking for the b squareds first, because that's our highest exponent. So I'm going to add those numbers in front. So 5b squared plus 2b squared is 7b squared. Then I want to look to see if I have any b's. I've got this 2b, so I'll do minus 2b. And then we've got this minus 2 here. And that is where our answer stays. So what happens as you do these add and subtract questions is you're going to see that they all get treated the same. After we get rid of those parentheses, we want to combine like terms. Now, if we are subtracting, notice how the signs switch on both of the two terms in the polynomial that we're subtracting. If we're adding, the terms don't end up switching. So let's go ahead and take a look at another example here. We are actually going to go all the way down to question number 5. You can see this one's an addition question. The one we just did was a subtraction. So taking a look at this one, we're going to do it the same way. We're going to slap those ones right in front of those parentheses there, and we're going to distribute. So 1 times 8n to the 4th will give us an 8n to the 4th. 1 times negative n to the 3rd is negative n to the 3rd. Positive 1 times 2n squared is positive 2n squared. And positive 1 times 2n to the 3rd is a positive 2n to the 3rd. Now, just like we did in our last example, we're going to combine the pieces that look alike. We want to start from the highest exponent and then go down. So our highest exponent here is an 8n to the 4th. There's only one of those, so I will just write it. My next highest is an n to the 3rd, so I've got a negative 3n to the 3rd and a positive 2n to the 3rd, or negative 1n to the 3rd, excuse me. Negative 1n to the 3rd and a 2n to the 3rd. Negative 1n to the 3rd plus 2n to the 3rd is a positive 1n to the 3rd. Now, you don't have to write this one here, but you totally can. Not right, not wrong, just a way that you can do it. Then we've got 1n squared, or one term with an n squared, and it's a 2n squared. So we end up getting this 8n to the 4th plus 1n to the 3rd plus 2n squared. So you can kind of see how this works here, where we're throwing in that number in front. So we can do this regardless of how big those polynomials that we're adding end up being. So as you take a look down at question number 7, it ends up being the same way. We're going to slap those ones in front of the parentheses there, and we're going to distribute. So 1 times 2a to the 4th is 2a to the 4th. 1 times negative 2a to the 2nd is negative 2a to the 2nd. 1 times 7a to the 3rd is 7a to the 3rd. 1 times 4a squared is 4a squared. 1 times negative 4 is negative 4, and 1 times negative a to the 3rd is negative 8 to the 3rd. Now we're lucky enough that we get to combine the terms together that look alike. We've got 2a to the 4th, but one term with an a to the 4th, so we'd write 2a to the 4th. We've got two terms with an a to the 3rd. We've got the 7a to the 3rd and then negative a to the 3rd. Remember, this is really the same as a negative 1a to the 3rd. So 7 minus 1, or 7 plus negative 1, is going to give us a positive 6a to the 3rd. We've got two terms that have an a squared, that negative 2a squared and the 4a squared. So negative 2 plus 4 ends up giving us a positive 2a squared. Then we've got one more term left, and that is our negative 4. So we will go ahead and put that on there. Now, notice how I end up labeling all of these different terms using different notations. That's super helpful when it comes into trying to decide which terms go with each one. Now, As you continue looking, you can see that they end up the same there. Our 9 will look very similar, where you're just distributing that one in, you pop them in front, and you distribute it in. This time you're just going to distribute it to all of the terms, just like we did before, right? So rather than going through number 9, I'll have you do that on your own. Now, there is one more that I want to take a look at. So if you'll go ahead and turn to the back there, we're going to take a look at question number 14 here. Oh, maybe. Question number 14 here. Now, on question number 14, how many sets of parentheses do you see? That's right. Question number 14 ends up giving us 3 sets of parentheses here. Now, the cool thing, maybe it will let us go back to drawing. There we go. It's got 3 sets of parentheses there. Now, the cool thing about adding and subtracting polynomials is it allows us to add and subtract as many as we need to. And we use the same process. So in front of every new set of parentheses, I'm going to put a 1. And we're going to treat it just like we did before. So 1 times 1 is 1. 1 times negative 6p squared is negative 6p squared. Now I could go to my next set. Positive 1 times p squared is positive 1p squared. Positive 1 times 5p to the 4th is a 5p to the 4th. Now I get to distribute this negative. So negative 1 times 3 is a negative 3. And a negative 1 times 7p to the 4th is a negative 7p to the 4th. Now we just get to combine those pieces that look alike with one another. So we want to start with the highest exponent. The highest exponent that I see is this p to the 4th, and I've got 2 different terms with that. I've got a 5p to the 4th and a negative 7p to the 4th. So 5 plus negative 7, or 5 minus 7, is going to give us a negative 2p to the 4th. Now, I don't have any p to the power of 3s, but I do have 2 sets of p to the power of 2s, our negative 6p squared and our positive 1p squared. So negative 6 plus 1 is going to give us a negative 5p squared. Then our last term here is our constant. So it doesn't have any variables with it. We've got a positive 1 and a negative 3. 1 minus 3 gives us a negative 2. So you can kind of see how that works. You're going to do the exact same thing on all the others. If you have questions, don't hesitate to ask, but that is how you can add and subtract those polynomials, by just slapping those ones right in front and then making sure that it gets distributed all the way across, regardless of the question. And make sure when you distribute, you remember to take that sign. So a positive 1 if it's positive, a negative 1 if it's a subtract. If there's no sign in front, remember that means that it is positive.